Hello everyone, I am Tejas Patil, and today I'll be presenting on the topic random forest, its advantages and limitations. Starting with why introduction. Random forest is an ensemble learning algorithm that builds a large number of decision trees and combines their results using majority voting for classification or averaging for regression. The reason it's important is that large datasets often have non-linear relationships, which are difficult for simple models to capture. Random forest handles these complexities effectively and still maintains accuracy even with high dimensional data. To explain this with an analogy, think about movie reviews. If you rely on a single critic, you may get a biased opinion. But if you take reviews from 100 different critics and combine them together, the extreme biases get cancelled out, giving you a more balanced opinion. That's exactly how random forest works. Aggregates diverse perspective from multiple trees to make a reliable decision. The next is content description. In random forest classification, tasks are handled by majority voting, while regression tasks uses averaging of predictions from all trees. It can handle both categorical and continuous variables, making it very versatile. By combining predictions from diverse trees builds on a random subset of data, it reduces overfitting and improves accuracy. For example, you can imagine we want to classify a fruit as apple or banana. Use five decision, and we are using five decision trees. If three predicts apple and two predicts banana, then majority voting, the final answer is apple. This simple mechanism makes the model both robust and accurate. The working of random forest. Let's see the working of random forest, and it happens in three steps. The first step is bootstrap sampling. Random subset of data are created with replacements. With replacements means that we are picking a data point and we put it back into the data set, so it can be picked again. So different data sets can have same element, and each subset trains on a decision tree. The next step is training. Each decision tree learns different aspects of data. Since each tree sees a slightly different subset of data, or you can say there are different elements, so different trees learn different patterns. For example, one tree may focus on color, another may focus on size, and another on weight. Then the last step is aggregation. Final prediction from all trees are combined. For classification, as we know, we use majority, and regression, we just take the average. So if two predict apple and one predict banana, the final result is simple. It will be apple. So let's discuss some challenges which are present in random forest. Random forest, it is a basically a black box model. We cannot always interpret it why it made a particular decision. We cannot tell it is made because of credit score or there is another reason. It is not, we cannot interpret it, and it works better on huge amount of data. It requires a lot of data. So training requires building many trees, which can be slow and memory intensive. Sometimes feature selection or dimensionally reduction like PC is needed. So we work on PC1 and PC2. In regression, it cannot extrapolate beyond the training data range. For example, in loan approval, let's take an example of loan approval. Random forest may reject an application because 68 out of 100 trees voted no. But we cannot explain clearly whether income was highly influential or credit score or age had the most influence. This shows that we don't know why the model took this decision. What was the reason behind it? The model hides those details. This is uh, the major drawback of random forest. So let's see. So from all this, we can conclude that random forest is a powerful algorithm that increases accuracy and reduces overfitting. It handles both categorical and numerical data and works well on high dimensional datasets. However, it does have challenges. It's a black box model, needs more computational power, and lacks easy interpretability. Some of the applications of random forest are: it is used in finance for credit scoring and fraud detection. It is also used in healthcare for disease prediction and diagnosis, in marketing for customer segmentation and recommendation systems. That's why random forest remains one of the most reliable and widely used algorithms in machine learning. Thank you.